Hello, this is Ms. Moreland. Welcome to the final lesson, lesson 6 of chapter 5, besides the review. So we're talking about parallel and perpendicular lines today. Should make this quick. If at any point you know the answer, pause the video, write down your answers, and just fast forward to the answers. So to start with parallel, these two lines look very parallel, so I'm going to find the slope real quick of them. Right, so it looks like I need to go up 3 and over 1, 2, 3, 4, 5. This one I go up 1, 2, 3, and over 1, 2, 3, 4, 5. Notice that they are both the slope of 3 over 5. And we're going to check these ones. I go up 3 and over 1, 2, 3, 4, 7. And remember, I have to put a negative because I went to the left. Up 3 over 1, 2, 3, 5, 6, negative 7. So notice these both have a slope of negative 3 over 7. Okay, so what do you notice about parallel lines? You notice that lines are parallel if and only if their slopes are the same, exact same sign and number. And let's look at these. These are perpendicular, it looks like. So I'm going to find the slope. So I'm going to go up 2, it looks like, and over 1, 2, 3, 4, 5. So the slope of that one is 2 over negative 5. And this one looks like I'm going up 1, 2, 3, 4, 5, and over 2. So the slope of that one is 5 over 2. So we call these two things opposite reciprocals. And what that means is they have to be flipped. So if I start with 1/2, I would flip it to 2 over 1. That's the reciprocal part. Opposite means one has to be positive, the other has to be negative. So let's check and see if it's true for these two. Looks like I go up 3 and over 1, 2, 3, 4. So the slope of that green one is 3/4. So if we were thinking ahead, we would think, oh, the slope of that next one needs to be negative 4/3. So let's check and see if that works out. Up 1, 2, 3, 4, and negative 3 over. And so did we get a slope of negative 4/3? Negative 4/3 and 3/4 are opposite reciprocals. So lines are perpendicular if and only if their slopes are opposite, meaning they have to be different signs. One has to be positive, the other has to be negative, and they have to be reciprocals. It means you just flip it. Reciprocals means you just flip it around. Okay, so let's start with a couple examples. Again, if you know these, fly through them real quick and fast forward through the answers. So this is the example we just saw. Remember, slope is always next to the x, so we have a slope of 4/3 or 3/4 and negative 4/3. So these are perpendicular, and sometimes you might see that symbol used for perpendicular. Look at the next one. One slope is 2/3 and one slope is 3/2. Now they're reciprocals, but they are both positive, so this is an example of them trying to trick you. It's not perpendicular because they're not opposite signs. This one has a slope of 1/2. It's next to the x. 1/2 next to the x, so these two have to be parallel lines because they're the same slope. So these first three are pretty easy. And so is this one. We have a 4 and a 4, so these are parallel. Oh my goodness. Terrible handwriting still, and I'm on the last video. Parallel. And I have one more question I want to ask. If I wanted the opposite reciprocal of 4 over, I would have to put 4 over 1 if I wanted to find the reciprocal, and I would notice that it's 1/4. So that's just a side note that if you see a whole number and you're going, what's the opposite reciprocal? It's 1/4. Right. Now we get to some more challenging ones. So this one, I have it in standard form, so I'm going to need to solve in order to get the slope. So I'm going to subtract 3x from both sides. So 9y equals 18 minus 3x. And I'm going to divide by 9 on both sides. Remember, it was okay to leave it like this in your benchmark, but now I need to separate out into 18 over 9 minus 3/9 x. 18 over 9 is the same as 2. And 3/9 is the same thing as 1/3 x. So I end up with my equation being y equals 2 minus 1/3 x. So now when I compare the slopes, one slope is 3, the other is negative 1/3. 3 over 1's opposite reciprocal is 1/3, and 1's positive, 1's negative. So these two are perpendicular. Hope you can read that, perpendicular. Sorry, a little slow at writing and probably did not say something. All right. The next two are close. I don't have to solve really for this one because notice this is the slope, it's an mx plus b. And this is the slope in point slope form. So I hope you're saying, oh, that was easy. These are parallel. The last thing we're going to do is go over how to write an equation and how to use this in context of geometry. So to write a parallel equation, you would just have to have the same slope. So that's an example. All I did was change the y-intercept. This would be an example. Change the y-intercept. So all I'm looking for when I ask you to write a parallel equation is that it's got the same slope. The y-intercept has to be different. Okay, perpendicular is the same idea. I don't care about what the y-intercept is. I just need to make sure that I make it opposite reciprocal. So if I take 2/3 and flip it, that's the reciprocal. And notice that this one is negative, so I need to keep that one positive, and I can just write whatever y-intercept I want. Pause the video and write it for the next two and see if you can do 3. So I'm going to give you an example of one parallel equation. Again, you can have whatever number you want back there. I'll give you an example of one perpendicular. The opposite reciprocal of 2 is 1/2. And notice that one is positive, so I need to make this negative. And I can put whatever number I want on the end. Okay. The next one is in point slope form, which isn't too bad. I just need to make sure I know what the slope is. And I see that the slope is 4. So if I wanted to write any parallel equation, I would just be looking for the 4x, and I don't care what the y-intercept is. And if I wanted to write a perpendicular, the opposite reciprocal of 4 is 1/4. And since the slope of this one's positive, I need to make it negative, and I could do that. Does not matter what the y-intercept is. And the last one, I'm going to have to use my solving skills. I'm going to add 2x to both sides. Divide by 3. So I get my final equation to be y equals 6 divided 3 is 2. And 2 divided 3 is just a fraction. So I see that the slope is 2/3. So again, parallel. I don't care what the y-intercept is as long as I have the same slope. And perpendicular, the opposite reciprocal is negative 3/2. And I could even give you the same y-intercept. So your answers don't have to match the y-intercept. All I'm looking for the slopes. All right, so this last one is kind of a word problem, kind of a scenario of what you're going to see in geometry. This shape is a quadrilateral because it has 4 sides, and we have something called a parallelogram, and all that means is it's 2 sets of parallel sides. So all I need to do is find the slope of each side. So that goes up 1, 2, 3, 4, 5, and over 1, 2, 3. I'm going to do the same with this one because that's the opposite side. So it goes up 1, 2, 3, 4, 5, and over 3. So far I know that AD has a slope of 5/3 and CB has a slope of 5/3. Right, so now I have one left to do. I'm going to do these two sides. And notice these ones are easy. A horizontal line you should be thinking has a slope of 0. So I know that AB has a slope of 0 and DC has a slope of 0. So notice that these two are parallel and these two are parallel. And notice my definition says it just needs 2 sets of parallel sides. So it says show that ABCD is a parallelogram. AB or AD, we're going to use that symbol for parallel. We'll talk about that later, is parallel to CB. And AB is parallel to DC. So it is a parallelogram. And we'll discuss more of these in class. Okay, I don't expect you to know the definition of parallelogram, but you do now see that 2 sets of parallel sides makes it a parallelogram. Right, try to do the on your own, and I will see you tomorrow.